Okay, we will continue. Okay, so you have this chlorate 5 ions are powerful oxidizing agents. Okay, they mentioned that they are powerful oxidizing agent. So if they are powerful oxidizing agent, they are going to oxidize others, but at the same time they are going to get reduced. Okay, when they are going to be reduced, okay, do remember oil rig. Okay, reduce is gain of electron. They are going to be gaining electron. So this is going to be important because later when we want to try to balance the equations, okay, it's going to be very important. Now, here they mentioned that if the reduction, okay, of this yeah, of this ion, okay, SO2 forms CaO2 and sulfate ions as only products. So you need to balance the equation. Now, for any equation related to redox, okay, I will strongly advise you to do it in a half equation form. Okay, don't balance it directly. So let's do the half equation. So if I put it in a half equation form, okay, so you see ClO3 minus, okay, they are going to be forming ClO2. And do remember, this is going to be a powerful oxidizing agent. It means that they are going to gain electrons. So just in case, I'll just put it over there. Okay, they are going to gain electron. It's okay, Aneta, no problem. So here, okay, if you have the gain of electron, and then the second one is going to be the SO2 is changing into SO4 2 minus. Okay, so if this one is going to be something is gaining electrons, so of course here will be okay, plus electron here. Okay, so anyway, okay, we try to work using this first. Okay, you see here, the first thing is they say that there is the only product is going to be ClO2 and SO4 2 minus. But if you want to balance this, there is no way just simply balancing this with the existing elements or ions. Okay, why? Because you can see the ClO3, okay, minus, and then you have ClO2. So there is another one more oxygen that is missing. So you include that oxygen in form of water. Okay, you include in form of water. And when you include that in form of water, then you include here H plus. Okay, you include H plus, and then you try to balance this up. Okay, because you see H2. Okay, so everything is balanced except for hydrogen. So I will include 2 there. Okay, and then okay, we try to balance the electrons. Okay, the electrons, how many electrons should I add? You see here on the my product side is going to be 0 charge, and then at my reactant, okay, I have -1 and then 2H plus, so it means +2. So I have total charge of +1. I want to make it left and right, okay, must be the same charge. So what I need to do, I need to add 1 electron, okay, 1 electron, so that I have the plus -1, so that you get 0. Okay, so that is going to be to determine how many electrons should I add. Okay, now let's move on to the second equation. This is equation number 1. So second equation, SO2 to give you SO4 2 minus. So similar, we know that water is being formed, but water must be cancelled because they mentioned that the only product is ClO2 and SO4 2 minus. So of course water needs to be cancelled. So I need to put, okay, H2O over here. Have to, no other choice. Okay, so if I put the H2O, and then I want 4 oxygen, so the best way is to put 2 here. Okay, and then there is no H plus here, so I need to put H plus, and then there are 4 H plus. Okay, if you count over here, 4, and then the last one is to balance the charges. Okay, the charges you see here, the charges are 0, and then if you see the charge here, -2 plus 4, it's going to be +2. But I need to make sure left and right are 0. Okay, according to what we have over here, must be the same charge. Okay, so 0, and how to make it 0? +2. I need to plus -2. How do you get -2? By adding with 2 electrons. Okay, you add with 2 electrons. So now the charges and everything, they are balanced. Okay, so left with just adding all of them together. Okay, but okay, we need to make sure the electrons are going to be balanced as well. Okay, so what we do, okay, 2 electrons and 1 electron, you need to times everything by 2. Okay, so times by 2, 2, this will become 4, 2, and 2. So when you add, okay, this water will cancel. When you add, the H plus will cancel, the 2 electron will cancel. So this one will look like what they mentioned. You are going to get something where there is no other products that is going to be formed. Okay, so you will get this. So your work is just to put it over here, and that's going to be your answer. Okay, so that is how you balance, okay, by using the information here, okay, and then try to balance. Okay, now the next question is going to be chlorine dioxide. Okay, this proportionates with hydroxide ions, okay, to form a mixture of ClO2 minus and ClO3 minus ions. What is meant by disproportionation? Disproportionation is going to be the same substance has been uh, has been both oxidized and reduced at the same time. So we that is our explanation, but you still need to mention about using this reaction example. So you need to calculate the oxidation number to show, because not enough by just explaining oxidized and reduced. So on based on what you know that they are going to be oxidized and reduced. So based on what? Okay, so you need to calculate the oxidation number. So let's calculate the oxidation number of Cl in ClO2. So this is x, okay, minus 4, 2 times negative 2 equals to 0, x equals to 4. Okay, you can see 4 and 4. So now let's say I'm going to calculate for Cl over here. So x minus 4, okay, equals to negative 1, x equals to negative 1 plus 4, I'm going to get plus 3. So this is going to be plus 3. So this is going to be ClO2 to become ClO2 minus. Okay, you are going to get this. Include that information. Okay, this is going to be reduction. So the next one is going to be this. So you just put x minus 6 equals to negative 1. So x equals to negative 1 plus 6. So it's plus 5. So this is plus 5. Okay, so this one is going to be ClO2 to become ClO3 minus. So this is going to be oxidation. So make sure you involve all this information to get that 1 mark. Okay, you need to calculate. If you don't calculate, okay, forget it. Okay, you are not going to get the 1 mark. Okay, deduce the ionic half equations, okay, for the reaction in B1. Okay, so deduce, okay, this one is going to be, if you want to deduce this reaction, just put, okay, because ClO2 to ClO3 minus, okay, ClO2 to ClO3 minus, okay, that's the equation. And then I also have another equation, which is going to be ClO2 to become ClO2 minus, okay, this equation. So how do I deduce the half equations for that? Okay, quite simple also. You see here, when you have this ClO2 to become ClO2 minus, okay, we know that this is going to be reduction. Okay, reduction is going to be gain of electron. So when I see here, there's nothing changed, ClO2, ClO2. So I just put gain 1 electron. So you get minus. No need to add anything. Okay. So that is going to be how did I end up with this half equation. Very easy. But the second half equation maybe need to do extra stuff. Okay. What is the extra stuff that I need to do? Okay. Because there is ClO2 and there is going to be ClO3 minus. Okay, there is going to be one more extra oxygen. Okay, one more extra oxygen. But again, they say deduce. Okay, don't simply do something new. Yeah, when they say deduce, okay, you see this reaction automatically changing into this. So another reaction is there is an involvement of OH. Okay, it means there is ClO2 is reacting with OH. Don't go and simply put, okay, ClO2, ClO3. So here must have water. Don't do that. Okay, don't do that. Okay, cannot just directly use the one that we always use. So this one is deduce. So you deduce using what you have, OH. You add OH here. Okay, you add the OH here. And when you add OH, okay, what is going to happen? You are going to get, in this case, must get water. Okay, because in the previous equation, there is no water. So I included water. And then I try to balance. Okay, I try to balance because if I put water over there, I'm going to get 4 oxygen. But now I'm only having two oxygen. So I need to make sure I have 4 oxygen. So I put 2 OH minus. So when I put that, my hydrogen also will be balanced. So the only thing that I need to balance now, okay, because the charges, you see, the first equation, the charges is going to be -1. This is -1, it's okay. But the charges over here is going to be 2 negative. So -2 on my left hand side. The charges over here on my right hand side, this is 0. Okay, so this is -1. So I need to make sure my charge, okay, on my left and right is going to be the same. So it's -2. The only way to make it -2 is going to be by adding another electron here. So I'm going to get plus -1. So I get -2. Left and right is balanced. So that is where I get this equation. Okay, deducing. So maybe this equation easy. Maybe this one might be confusing. Okay, but I already told you how to get it. Yeah. Now, next is going to be a lithium iodide electrochemical cell can be used to generate electricity. They have this lithium electrode and inert electrode immersed in body fluids. Okay, when the current flows, lithium is oxidized and iodine is reduced. Okay, use the data booklet to write the half equation for the reaction taking place at the 2 electrodes. Okay, so they mention half equations. Don't go and write standard reduction potential. Okay, so it means you need to tell which one is oxidized, which one is reduced also. Okay, you need to adjust accordingly. So hence write the overall equation. So I know now they say lithium is oxidized. So it means lithium, okay, you are using lithium. So lithium is going to be oxidized to become Li plus. Okay, so I just Li, how Li can become Li plus, because Li plus is group 1. Okay, so Li plus, so you lose electron. So you lose electron. So I put the plus electron on my right hand side. And then another one is iodine is reduced. So I2, okay, is 0. So reduced means, of course, I minus. Okay, so it means it must be 2 minus, also 2I minus. So I just put it over here. How do you get from neutral to become I minus? So plus electrons. So how many electrons? 2 electrons. So I put it already. And then write the overall equation. Yeah, so you need to put the 2 to cancel the 2 electron, and you will get the overall equation as this. Quite easy. Yeah, quite easy. When I look at the, okay, my data booklet, this is the standard reduction potential that I will get. Okay, Li plus plus electron to give you Li negative 3.04. And then I2 plus 2 electron, okay, 2I minus, positive 0.54. This is very important because, okay, now I know, okay, which one is more positive. I know that 0.54 is more positive. This will go forward and this will go behind. So when it goes behind, this one will become positive 0.3, positive 3.04. So when they ask you to calculate the E cell, I will calculate the E cell, okay, using this method, because this is moving forward. Since this one is moving forward, so 0.54 positive. This one is going to move backwards. Okay, so it's going to be plus 3.04. So when I add this, I'm going to get 3.58. So when you write down, make sure you write positive 3.58. Next, a current, Okay, a current is going to be drawn from this cell. So this is the current. We are going to calculate the time taken, okay, for the 0.1 gram of lithium electrode to be used up. So basically Li plus electron to give you Li. Assume the current remain constant throughout this period. So here, first of all, if you have 0.1 gram of lithium, calculate how many moles first. Okay, so when I calculate this one, you get it from your periodic table 6.9. Okay, you will get this number of moles. And then, okay, when you look at the charge, okay, Q equals to IT. Okay, so you just put, okay, the current with the time in seconds. Okay, in seconds, that's going to be the current. Okay, that's going to be the charge. Okay, that is going to give you 0.1 gram of lithium. Okay, so based on what I have over here, this one we have learned every 1 mole, okay, every 1 mole of this 1 mole of electron, so we call it 1 Faraday, the charge, okay, for 1 mole of electron is going to be 1 Faraday. So that 1 Faraday is supposed to give you 1 mole of lithium. So I just put there. So 1 Faraday, I know the charge. Okay, this one we normally memorize 96500. It's going to give you 1 mole of lithium. Now I don't have that column. Okay, 96500. Okay, so I do not. The column that I have, okay, is going to be. I need to find out what is going to be the column that I have. Okay, because if I have 1 mole of lithium, then 96500. Okay, but now I don't have 1 mole of lithium. I have this amount of mole. Okay, so what I do is I just need to times this by 0.01449. So this one also you times with 0.01449. Okay, and you will get the column. Okay, you will get the column, which is going to be, if you do that, you are going to get this value. Okay, so where do we get this? Okay, you are going to get, okay, you are going to get from 96500. Okay, you times with 0.01449. That is going to be the column, and that columns that is going to be related to this. So you just need to put 1398.55 equals to 2.5 this and time. Calculate the time in seconds. Okay, this is going to be the seconds. When I calculate, I'm going to get this. Okay, I'll stop for a while for any questions. Charlton, okay. Can I hear you, Charlton? Everything okay?
Yeah.
Jason, is everything okay? Can follow? This is okay. Yeah, this question is quite okay. I think the one that I find it challenging a bit is the one that we did earlier, where we need to use the calculation to prove for Avogadro constant. Yeah, that is something that is very interesting. Okay, this one is still okay. Okay, so please practice on this. Okay, generally that's going to be 3 marks or 4 marks maximum. Okay, so please remember how to use this. Okay, it's one of the very popular questions, okay, in your paper 4. Now, so let's move on, okay, to question number 4. Sketches of the shapes of some of the atomic orbitals are shown. Okay, so identify the type. So you have SP or D. Now D we don't really study, okay, but we have learned about S and P. So of course the another one should be D. So you see S is going to be spherical, okay, so therefore this is going to be S. P is going to be a dumbbell shape, okay, so it's going to be P, and then left with one more, it's going to be D. Okay, so cadmium forms the 2 ions. Okay, they have given the 2 ions and the electronic configuration is given. Now use this information to explain why cadmium is not a transition element. So talking about the definition of a transition element. Definition of transition element is going to be an element that can form one or more stable ion. Okay, one or more stable ion with incomplete D subshell. Okay, with incomplete D subshell. So whenever you see here, the D subshells are all complete. Okay, so this cadmium is not a transition element because okay, the D subshells are complete for both of the ions. Okay, D subshells are complete. Or you want to just use, um, if you want to use this approach, you say that, okay, cadmium is not a transition element because it doesn't form one or more stable ion with incomplete D subshell. Okay, so different ways of answering. C. Methylamine is a monodentate ligand. Okay, state what is meant by the term monodentate in this context. Monodentate means, okay, it has one lone pair that can be donated to metal ion. Okay, so because we don't say donated just like that, you can just say methylamine, okay, can form one dative bond, okay, one dative bond by donating one lone pair to the metal ion. Okay, so what is meant by monodentate? Okay, so monodentate donates or forms one dative bond with metal ion by donating one lone pair to the metal ion. Donating or forming a bond by donating one lone pair. Okay, depends, okay, how you want to put it. Okay, but do remember, okay, the dative must be there, lone pair must be there. Okay, but in this question, I think they only focus on the lone pair, but the marking key, okay, will be a little bit more flexible, so they will say they'll accept one dative bond or one lone pair, still fine. Okay, so that is going to be the answer for this monodentate ligand. So in the presence of aqueous methylamine, okay, this one reacts with to form a mixture of two isomeric octahedral complex. Complete a three-dimensional diagram to show the isomer. So they are asking you to use L to represent the CH3NH2. Okay, so it's a monodentate. It means each one is you are going to have one L. Okay, each one is going to be one L. So the only thing that can exist over here is going to be cis and trans. So one is going to be side by side, another one is going to be opposite. So you can just draw, okay, side by side, and another one is going to be opposite, but just be careful, okay, H2O, the lone pair is coming from oxygen. So when you write H2O in this form, okay, write down OH2, okay, or you can also write it in this way, it's also okay, fine. Okay, as long it is going to be, it looks like it's connected to oxygen. And very important, okay, some students always ask, can I just simply use this? Don't. Okay, always use this method. If you don't show the 3D dimensional diagram in this way, you are going to be deducted mark. Okay, the two triangle that appears to come out, okay, that is actually coming out from the piece of paper. The two lines over here, this is assuming that it is going behind. Okay, so this is going to be cis, this is going to be trans. Next question, state what is meant by the term stability constant. Okay, stability constant is like something like Kc. So it's an equilibrium constant for the formation of a complex ion in a solution. So like for example, in this, okay, it's like something like Kc. Okay, but we are not going to involve water. Okay, we are not going to involve water. So this one divided by this to the power of 4. Okay, so that is going to be K step. Okay, stability constant. Complete the table by placing one tick in each row to suggest how increasing temperature will increase the K step, or how it will affect the K step. Do remember, temperature only will affect K step or any Kc. Pressure, pressure concentration will not affect, okay, K step or Kc. And the equilibrium concentration of cadmium complex. Okay, quite simple. Okay, because this is going to be negative. Okay, if it is negative, I told you to put your hand and then just put it's hot. Okay, so this one, put your hand. This is going to be cold. So when I increase the temperature, I need to decrease the temperature. How do you decrease the temperature? By moving from hot to cold. So the position of the equilibrium is shifted to the left. Okay, so it depends on how you answer the question over here. So here, okay, the K step is going to decrease. Why? Because you are going to form more reactants. Okay, so it's supposed to be this, okay, divided by this. Okay, of course, this one, if it is this one is decreasing, the entire K step will decrease. And then they also ask about the concentration of this ion. So since it's moving backwards, so of course it's going to be decreased as well. Okay, so explain your answer. Okay, higher temperature will favor what type of reaction? Okay, higher temperature will favor, this is going to be exo. So they are going to go behind. So it's endo. So higher temperature favors endothermic reaction. And therefore, the reaction, okay, moves backwards. Okay. Or the position of the equilibrium shifted to the left. Okay. So if you mention that, you will get a full mark. In the marking key, they say that the forward reaction is exothermic. That's why, okay, higher temperature will go backwards or something. But it's still the same answer. Temperature is high will favor endothermic reaction, which is going to favor the backward reaction. The moment you mention that, you will get the solid 2 marks. EDTA4 minus is a polydentate ligand. When a solution of EDTA is added, a new complex is formed. So here you have two stability constant. So a solution containing equal number of moles, okay, so they are giving equal chances for the competition of this ligand exchange. So they are telling predict which complex is formed in the larger amount. Okay, this one you just need to focus on the higher K step. Okay, so the one that is going to be formed more is going to be 10 to the power of 16. So it means the EDTA ligand is more stronger, okay, compared to the CH3NH2. Okay, so this is going to be the EDTA that will give you the 10 to the power of 16. Okay, it's going to be formed in a large amount. So to explain that, explain your answer, just tell, okay, this one, okay, because K step is higher than the other. Next question, methyl amine is a Bronsted-Lowry base. Okay, Bronsted-Lowry base is going to be, they say Bronsted-Lowry, they say it's a proton acceptor. Okay, any base is a proton acceptor. So methyl amine is going to be a proton acceptor. So you need to think about in that perspective. Write an equation to show methyl amine dissolve in water to give an alkaline solution. So I just put this one, okay, plus with water. Okay, water will have H plus and OH minus. So I was thinking that it's a proton acceptor. This is proton. So H plus will go and join here. Okay, so you are going to get CH3 and H3 plus, and then left with OH minus to show that it's an alkaline solution. Now, initially I put the arrow as a single arrow, but when I check in the marking key, they put a double arrow over there. But for me, okay, since they just say write an equation and they didn't mention that the reaction is going to be reversible, there is no way for us to deduce that it's going to be reversible. So For me, okay, if you just give your answer without the presence of the double bond, it's still correct. Okay, but okay, if this one you want to learn, okay, it's going to be a double reversible reaction, then you include. Okay, but here, if you give a straight line to form, okay, like for example, one arrow like that, then I'm fine with that. Okay, this is I'm fine with that. Okay, you will not be deducted mark. Now, next question is methylamine is a useful reagent in organic chemistry. So construct an equation, okay, for the reaction. They didn't say must follow what kind of equation. So anytime whenever I'm dealing with organic compound and then they ask me to write an equation, the best way to see is by using structural formula. Okay, this one I've seen many times. Don't use the full formula, like for example, C2H3OCl. No. Okay, it is much more easier if you can represent using structural formula. This is ethanol chloride, and this is going to be methylamine. Okay, methylamine. And then what will happen? The hydrogen, one of the hydrogen will join with the Cl to give you HCl. So the rest is CH3CO, and then they will join with this and one of the hydrogen here. Okay, so the nitrogen. Okay, they will join with the nitrogen. Okay, so when they join with the nitrogen, so left with this. So that is going to be the equation. Methylamine also reacts with propanol. Okay, this is propanol. It's a carbonyl compound. Now, carbonyl compound, by this time, because you are in A2, you should know carbonyl compound, they always have this mechanism of reaction, which is going to be nucleophilic addition. So that it will be something that will be playing in my head. Okay, maybe they are asking about nucleophilic addition. Okay, but don't simply just give your answer. You need to analyze properly. When this reaction is happening, I am going to get, okay, this P. Okay, but if I want to deduce the type of the reaction over here, okay, the type of reaction is going to be, I can see that water is being removed over here. Okay, if water is being removed over here, the the I think the type of the reaction, it can be also written as condensation reaction. Okay, because water is removed. Okay, but the best answer is not condensation. The best answer is going to be it's a very special type of reaction, because generally we think it's a nucleophilic addition reaction, but it's a very special. Why? Because first of all, okay, when I have CH3 double bond O, what happens is going to be the double bond O, okay, there will be, they will change into, okay, because it's more electronegative. Okay, so you are going to get CH3 and then O minus, and then one is pending. Now this O minus, they will join with one of the hydrogen here. Okay, one of the hydrogen here, so they will give you OH. And then the remaining compound, they will come and join over here, which is going to be N, remaining with H, and then CH3. Okay, you are going to get this compound. Now, this compound is not going to be stable. Okay, why? Because you need to form this. How that thing is going to be formed? The OH and H will be removed. Okay, this is going to be the dehydration. Okay, dehydration. So they are going to give you the double bond between the carbon and nitrogen. So carbon and nitrogen double bond. The OH and H is removed in this way. So here, okay, what type of reaction that is happening? Number one, because new bond is being formed, okay, with this compound, the nitrogen compound. So that is going to be already addition. Okay, that is going to be already addition. And the last one, when I'm trying to remove, okay, rather than saying it's going to be condensation, you can just put it as elimination. So there is a type of reaction that you need to know, which is addition elimination reaction. Okay, addition elimination reaction. Very rare they ask, but when they ask, yeah, they really want to test on this term, addition elimination reaction. Very, very popular. Okay, so far I've seen 3 questions asking about mechanism involving addition elimination. And also you need to know how to use this way of drawing using curly arrow diagrams and so on. Okay, but for this question, 13 marks. Okay, done. So let's look at the question number 5. Okay, before we go, any question for question number 4? Okay, let me check the chat. Okay, no problem. Yeah, so here, okay, if you have question number 5, you see chlorate 1 ion undergo the following reaction under aqueous condition. The series of experiment was carried out at different concentration, and the table shows the results obtained. Use the data in the table to determine the order of the with respect to each reactant. So this one is quite simple. Okay, why? Because when you want to find out the rate of reaction, okay, the rate equation, you just compare. Like for example, I see that okay, when I put from there must be one concentration must be constant, okay, so that I can measure. Like for example, experiment 2 and 3, I know that these two it's constant 0.4 and 0.4. So when I double this, okay, when I double this, what will happen here? Okay, you can see from 2 to become 8, this is going to be times by 4. So this is similar to times by 2 to the power of 2. Okay, so you can see this is going to be a second order reaction with respect to ammonia. So I put second order. And I also need to find out related to ClO minus. So how do I find out? Okay, I need to look, first of all, look whether, okay, ammonia is going to be constant, but I don't see any of the ammonia concentration is going to be constant. So you still need to use the basic assumption that, yeah, ammonia is going to be the second order reaction. So I'm going to use that to find out. So how to find out? Okay, we know that from here to here, okay, is going to be times 2, and here to here is going to be times 4. Okay, 1 and 3. Yeah, I'm talking about 1 and 3. So from here to here is going to be times what? So I need to find out. Okay, so 8.2 divided by 0 0.256. Okay, 8.2 divided by 0 0.256. I'm going to get 32. Okay, 32. And I know, okay, and I know that ammonia is going to be second order. So if this is going to be times by 4, this is going to be supposed to be times by 4 to the power of 2, which is going to be 16. So 32, okay, is going to be 16 times what to give you 32? Okay, because I want to get 32. So 16 times what to get 32? 16 times 2, you will get 32. Okay, and that 2 is coming from where? That 2 is coming from here. When you times by 2, then it's going to be times by 2. Okay, this part. So it means that, okay, if times 2, it means basically this one is going to be first order with respect to ClO minus. Anyone don't understand this explanation? Jason, can you understand this explanation? Why it's going to be power of 1? Jason? Jody, can you understand this?
The for ClO minus, yes.
Which one? Yeah. How do
I
you know
don't.
that it's going to be, how do I know that this is going to be 1? Okay, if you don't understand, okay, I can also show you using different experiment combo. Okay, if you are using different experiment combo, maybe we don't use the 32 you see here. If I want to use different combo, okay, maybe I use 2 and 3. So now maybe I use, just now I use 1 and 3, maybe now I use 1 and 2. If you use 1 and 2, you see here this is going to be times 2, this is also times 2. Okay, And I know that, okay, if I use ammonia, okay, times 2, because it's to the power second order, right? So if it is going to be second order, so it's going to be 2 to the power of 2. It means times 4. It must be times 4. But let's see, is it only times 4, okay, related to ammonia, okay? So 2.05 divided by 0.256, I'm going to get 8. So it's not times 4, it's times 8. So it means there is another one which is going to be 2. So that 2 must be coming from here. So you see, this one times 2, this is also times 2. So automatically, this is going to be um, first order with respect to ClO minus. Okay, there is no other way that I can show anymore. Okay, but this is going to be the moment you get that. Okay, that's going to be the reasoning. The reasoning, please use, okay, whatever way that I times just now. Okay, you need to show the working over here. Okay, explain. Okay, experiment 1 to 2. Okay, 1 to 2. When I do this, okay, this is going to be 8. Okay, so when I double, okay, this is going to be 2 to the power of 2, you mentioned, and then it must be double also. So therefore, I know that this Cl minus is going to be first order or something like that. And then you also explain about using equation, okay, 2 and 3. I found out, okay, that ammonia is going to be second order because of what? You need to mention. Okay, if you don't mention, you're not going to get the mark. Write the rate equation. Yeah, just simply write now. There will be K and then NH3 to the power of 2 ClO minus to the power of 1. 1 no need to mention, just put it there. Use the result in experiment 1. Okay, so they mentioned use the data in experiment 1 to calculate the K. So the rate is going to be 0.256. K, concentration of ammonia is 0.1 to the power of 2. Concentration of ClO is 0.2. So K is going to be 0.256 divided by 0.01 times 0.2. Okay, 0.1 to the power of 2 is 0.01. 0.256 divided by 0.01 times 0.2. I will get the K as 128. 128. Okay, let me check the answer. Okay, this is going to be 128, and then the unit. Okay, this is correct. The unit. Okay, so this is going to be 0.256 is going to be mole per dm cube per second, and this one is going to be, okay, to the power of 3. Okay, so mole dm negative 3 to the power of 3. Cancel this, then left with 2. So I'm going to have mole negative 2 dm positive 6 per second. Okay, that will be the answer. Next, on the axis, sketch a graph to show how the value of K changes as the temperature increase. K changes, only K will change when temperature changing. Okay, so rate constant, okay, they will increase. Okay, it's okay. Victoria's internet is bad. Later, I'll pass her the video. So the rate constant, okay, they will increase as the temperature increases. You can write down, okay, you can draw this graph. Or, okay, you can also draw, they do accept a curve. As long you can show that it is increasing with temperature. Okay, as long you show that it is increasing with the temperature. So it doesn't matter, it's going to be straight line or it's going to be a curve. Okay, it doesn't matter. Now, B, in another experiment, the reaction, okay, is going to be between chlorate and iodide ions. This one, please be notice this. A solution of iodide ions in aqueous alkali was added to large extent of chlorate 1 ions. So do remember last time I told you, in when you want to investigate only one particular ion involved in the rate equation, so we need to use another ion which is going to be large in excess because we want to make it to become constant. Okay, so they are mentioning this one is constant then. and I minus was measured at regular intervals. So now we want to measure the concentration of iodide, okay, iodide versus time because regular intervals. So you plot a graph, okay. So describe how the results can be used. So you get a graph, okay, concentration of I minus versus time. Once you get that graph, they say the confirm is first order. So if you want to confirm something, concentration versus time, okay, if you look at the graph, concentration versus time, there are three types of graph. One, it's going to be like this, okay, and that is going to be zero order reaction. And there will be two graphs that will be curved like this, okay. One of it will follow the half equation correctly. It means the half life is going to be constant, okay. So the constant half life is first order, okay. The half life that is non-constant is going to be second order. So it means now you want to find out that this is going to be whether it's going to be first order. First, you need to mention you are going to get a curve. Okay, you will get a curve, and after that, if you measure the half life, you are going to get a constant half life. Okay, and that is going to be enough to confirm that the reaction is first order with respect to this. A three-step mechanism is shown. So you see there is going to be a mechanism over here. Use this mechanism to deduce the overall equation. This one quite easy because they don't ask you to find out which one is going to be the slow step. Okay, because the slow step is going to be the one that we will use, okay, to tell that, okay, this is going to be involved in the rate equation and so on. But you can see here, roughly, okay, if I ask you to suggest the slow step for this reaction, you can roughly suggest the slow step because we know that the rate is going to be related to ammonia and then related to ClO minus. So if you look at the ClO minus, the ClO minus is only going to be involved here. And then, okay, but they say also chlorate and iodide. So this one is different, yeah. So it's chlorate and iodide, then they say it's going to be first order to I minus. So when I see first order to I minus, if I want to predict which one of these is going to be a slow step, the best prediction will be step number 2. Okay, step number 2 is the best prediction for the slower step. Why? The slower step must be having the one that has the one involved in the rate equation. So I minus is here. So that is going to be the slowest step. So if they ask, okay, but they didn't ask, okay, they didn't ask. So what they are asking now is going to be, they are asking us to use this mechanism to deduce the overall equation. This is very easy. This happens in 3 steps. So add all of them and see which one is going to be cancelled with each other. You see this one will be cancelled if you add. And then you can see water, left and right, they will cancel. HIO, they will cancel over here. OH minus, they will cancel over there. So leaving this behind, so ClO minus plus I minus to give you Cl minus plus IO minus. Very easy. Okay, this is going to be using the mechanism. Identify a step that involves a redox reaction. So this one, I end up calculating. Yeah, we need to calculate. Okay, so the calculation, when I do the calculation, the oxidation number is going to be -1. Okay, I just straight away go to step 2. Okay, to save time. Okay, so I calculated, and then this is -1, and I know this is -1. So I need to calculate for HClO. So easier if you put it as ClO minus. Okay, H plus ClO minus. So I just want to calculate for X over here. X plus -2 equals to -1. X equals to -1 plus 2. So it's +1. So this one is going to be +1. So you can see Cl from +1 to become -1. Okay, so there's going to be reduction. So let's calculate for this I over here. So similar, H plus, so IO minus. Okay, so if this is X, X minus 2 equals to -1, X equals to -1 plus 2. So you get +1. Okay, so this is +1. So from -1 to +1, so it's oxidation. So I know oxidation and reduction. So I found out that step number 2 is going to be redox. Okay, identify one step and explain. So you explain. Okay, step 2, and you need to explain I minus to become HIO. So it's going to be -1 to +1. And then you mentioned about HClO to become Cl minus. Okay, so from +1 to become -1. Have to mention. Okay, that is going to be giving you the 1 mark. Okay, it's done for today. Okay, so any